Hello everyone, I am Vivek, AGM RTC, Hyderabad. This session is about E4 E5 CM module, chapter number 6. In this session, this talks about KPI reports for 2G, 3G and 4G. So this is 6th chapter, and in this chapter what will be covered, this is the agenda. The key performance indicators, KPI stands for key performance indicators, and we will discuss about QoS, quality of service of 2G, 3G, 4G, and reports of KPIs, QoS parameters related to network accessibility, service accessibility and network retainability. So this is the agenda or the learning objectives of this presentation. Okay. This is as per the chapter number 6 of E4 E5 CM module. And coming to the what are the various KPIs in 2G, 3G, 4G we'll see. But what are the KPIs? KPI stands for key performance indicators, and we can also tell them as metrics. These are the performance metrics which will measure the performance of the radio network, performance of the core network, and basically in this chapter we are focusing more on the KPIs of the radio network, and the purpose of this KPIs, as I told you, this will be helpful to gauge the performance and meeting the expectations of the customers, and also to meet the vision of the management and the stakeholders of the company. And the KPIs may vary between the management, marketing people, or operations and network engineering people, depending on their priorities and depending on the perspectives. But basically these key performance indicators are these metrics. If they are good, the KPIs are good for any company, or if they are better for our BSNL, definitely they will bring good customers and they will retain the customers, and these KPIs will be acting like a key success indicators. Okay, so key performance indicators can become, if they are maintained well, they can become key success indicators for any company or also for BSNL. So what are the various KPIs right from 2G, 3G, 4G? Because in our BSNL, madam, oh yeah, okay, I will share it again. So let me share it. PPT is not available. PPT is not shared. Yeah. So here KPIs, as I told you, they are KPIs. They indicate key performance indicators, and KPIs, if they are maintained well for any company, they will become key success indicators, and which, if the success is there for any company, definitely it will bring good customers and good revenues and good profits for any company. For BSNL, we will be seeing 2G, 3G and 4G in this chapter, because for BSNL all these three networks are currently maintained. And as you have seen in this slide, it is talking about optimization. Optimization means this is a process in which we want to reduce the deviation between the planned and reality, planned activity and real activity. So what is this optimization? The planning team of any company or planning team of BSNL will do the RF planning, will do the core network planning, and they will give the blueprint to the operations team to deploy the network. The deployment team, after deploying and after making the equipment on air, definitely some issues will come, because the planned activity and realistic activity, there will be some issues because of the nature of the radio propagation, because of the practical issues like maybe path losses will be there, or new buildings might have come which are not there during the plan, or maybe some disturbances are there because of no seasonal change. Maybe planning done in different season, and in rainy season more water bodies will be there. Water bodies will reflect the signal, and which may affect the quality of service. So optimization team is always the process is they perform drive testing. They will carry out drive test to measure the different samples of different signals in different areas. The purpose is to reduce the deviation between the planned the plan and also the reality. So reality means the deployed network. Between the plan and the deployed activity, there will be some gap will be there. That gap they want to fill up. The purpose of filling the gap is because always everybody, any company or BSNL will try to adopt best plan. What will the best plan? The plan will be to give good coverage, to give good quality, to give good capacity to any service or to any service or to any customer. So service providers want to give good coverage, good quality and good capacity. So optimization team, what they have to do? Optimization team, they have to improve the coverage, capacity and quality. How? By reducing the gap between the plan activity, the plan and the reality. So that is the job of optimization. How they will be doing this activity? Of course, by simple answer is they will do drive testing. But after drive testing, how they will be, or what they will be measuring, or how they understand the performance, what are the various parameters, by which they can improve the quality, they can improve the capacity, they can improve the coverage. So these are called as KPIs. These KPIs, which will be also called as key success factors, these KPIs you can also call them as metrics, these performance metrics. Okay. As far as 2G is concerned, these are the different KPIs, and we will see these KPI, all these KPIs one by one. Coming to the first KPI, all these KPIs, as I told you, they are very much important to maintain the performance of the network. What is the SDCCH congestion rate? We will see one by one. SDCCH congestion rate should be higher or lower. First of all, it should be always lower. The SDCCH congestion rate should be always less as possible. It should be less than or equal to 1%. Lower the SDCCH congestion rate, better the quality of the signal. Okay. And what is this SDCCH? SDCCH stands for standalone dedicated control channel. So what is the purpose of it? This channel is a control channel used in the radio interface by the GSM network in order to perform an activity or a process called as LU process or location updation process. Location updation process is nothing but updation of a mobile phone terminal with the core network about its location, whether in which base station it is there, in which cell area it is there, in which location area it is there. So updating the location area of a mobile phone periodically, or whenever it switches off or switches on, or whenever it changes its location, it's called as location updation. And so this is a very frequent activity. You know how many times the mobile phone will be moving from one area to other area. Even if it doesn't move, periodically also this location updation should be done. And so many LU processes will be happening round the clock, and SDCCH is responsible for carrying out that feature. Apart from that feature, this LU is a feature which will be carried out in idle mode. Idle mode means the subscriber or the user may not be in a call mode, may not be doing an outgoing call, or may not be doing an incoming call. So SDCCH is also used for during call setup. when the customer want to make a MO call, mobile originated call, or a mobile terminated call, for incoming call or outgoing call also, for setting up, the SDCCH is used. And also it is used to deliver the SMS in idle mode. Idle mode delivery will not be done in a traffic channel, because traffic channel is a high bandwidth channel, whereas SDCCH is a low bandwidth channel. SDCCH is why it's called low band means in one traffic channel you can accommodate 4 or 8 SDCCH channels. So in one a traffic channel we can have 8 number of SDCCH channels. That is the beauty of SDCCH. It is occupying low number of resources, low number of radio bandwidth. So that is the reason it is used for SMS also. And if this is congested, if the number of SDCCH which are assigned by the OMCR or people, or with the number of SDCCH for every sector, for every BTS sector, for every BTS cell, if they are not sufficient to carry out the location updates, to carry out the setting up of calls or outgoing or incoming calls, or to carry out the load of SMS delivery, then there will be problems. What are the problems? Customers cannot suppose SDCCH congestion rate is there. SDCCH congestion rate is there means SDCCH are not available freely for the customers for location updation. If the location updation does not take place, the user will not be getting an incoming call. The user will not be able to use the services easily. He will not easily, he cannot use at all, and SMSs cannot be delivered. The call setup will not be done. So that will be a great problem, and it is a great discomfort to the users, and quality of service will be deteriorated. So to counter this, the SDCCH congestion rate should be always as low as possible as per the TRAI benchmark, because TRAI, Telecom Regulatory Authority of India, also earmarks certain numbers for every metric. So they have specified, they have standardized benchmarks for each and every KPI, and every operator has to follow it in order to maintain the benchmarks. The TRAI will also carry out the drive testing. Will also ask for drive test reports, and these performance reports will be published. The Kpi reports will be published for the public in their website periodically. Thereby they want to improve the services that they are rendered to the customers. And what are how the problem will be addressed. So let us see here one problem, several use cases of SDCCH congestion rate. Large traffic volume is there exceeding the network capacity. What is the problem? Suppose a network capacity is there and the traffic volume is suddenly increased, exceeding the network capacity. So how to address this problem? This problem can be addressed by increasing the cell capacity. So this is nowhere related to this, but we can increase the cell capacity. That is one of the solutions. Okay. And suppose more network capacity is less, we have to reduce the number of TRX. What are TRX? TRX are the nothing but transceivers. These transceivers are the capacity building blocks of any base station, of any BTS. More the number of TRX, more the channel carrying capacity, more the number of channels it can cater to. So if the traffic volume is increased, one of the method you can follow is increase the number of TRX if it's feasible. And coming to too many location updates at the LAC boundaries. So whenever you are finding this difficulty, whenever you are finding so many location updations happening at the LAC boundaries, LAC means location area code, then what is to be done? You have to adjust the LAC selections and modify the LAC boundaries, because there is since more number of location updations are happening means there is more number of movement at that boundaries. more number of location updations are happening, it is a burden on the, it is a load, heavy load on the network resources, radio network resources, core network resources. To reduce the burden, to reduce the load, to reduce the load on the resources available, less resources, you have to adjust the boundaries. And another thing what you can do is you can adjust the cell reselection hysteresis. Cell reselection hysteresis, so means what is the gap, how much dB CRH should be there. That also can be configured at the OMCR, and also this will enable to reduce the number of LUs. If you are increasing the CRH, cell reselection hysteresis, the advantage will be, so the frequent location updations will be reduced, and the frequency selection reduced, the load on the resources will be reduced. And we can also adjust the parameter setting of periodic location update timer. So there will be timer. So these are the different options, these are the different trials you can make in order to reduce the number of LU at the LAC boundaries. Okay, depending on the context, depending on the case, you can adopt different solutions. So you have to adjust the periodic location update timer T3212. So periodically, as I said, LU will be happening, that can be reduced. And when you see a problem like there is too much SMS traffic, then you have to implement this dynamic SDCCH allocation mode, and this will reduce the SMS traffic. Or you can also increase the SDCCH channels. So dynamic SDCC allocation mode means in a radio carrier, usually one carrier will be having 8 time slots. So in 8 time slot, 1 time slot will be dedicated for SDCCH channel. If you are adopting this feature, out of 8 time slot, you can, if your more congestion is there, SDC allocation can be 2. You can allow 2 number of SDCCH, 2 number of time slots for SDCCH channels. That means 2 time slots means 16 SDCCH will be there. If further demand is there, you can allocate 3 time slots. 3 time slots means 3 into 8, 24 SDCCH will be coming into picture, and it can cater to more SMS traffic or more SDCCH congestion rate. Okay. So these are the solutions that are available for the SMS traffic problem. Hardware fault. Whenever you are having any hardware fault in TRX or transmission system, obviously you have to replace the hardware, and you have to check and repair the transmission system. ABS interface means the transmission link you have to attend. You have to check the OF parameters or the media parameters, and you have to repair it. And unreasonable setting of system parameters and RACH parameters are there. The solution is the increase RACH stands for random access channel. Increase random access channel access threshold appropriately to cope up with the interference, and reduce maximum retransmission appropriately. So these are the solutions for these different various problems that will be there in the tool. In SDCCH drop rate. SDCCH drop rate means whenever any mobile phone is already in SDCCH, and in between communication is happening between base station and SDCCH channel got disconnected, it's called as SDCCH drop rate. SDCCH drop rate affects the location updations, as we have seen. SDCCH makes location updations, sets up the calls, and SMS in the, it carries the SMS in the idle mode. All these features will be affected. So obviously you have to optimize that. And how to optimize, we have seen several steps are there for optimization. What are the several steps? If your SDCCH are dropping means what? Maybe the coverage issues are there. Definitely what will be the one of the chance will be the bad RF or environmental factors. Maybe some coverage is less. Suppose or another option is maybe the neighbors are not properly defined. You have to properly define the neighbors in the OMCR. And as I told you, the low coverage. How to see the low coverage? Conduct a drive test, see where the coverage is low, and try to improve the coverage. How? To maybe by changing the power, maybe changing the antenna parameters, like down tilt, or changing the azimuth, or changing the altitude, or changing the antenna positions if it is feasible. So these are the various steps can be done. Interference. Interference is more. If the noise is more, signal to noise ratio SNR will be down. Quality of service will be down. Drop may be there. How to reduce the interference? So interference, how to reduce? The only thing is to reduce the frequency interference, 4-channel interference, 80-channel interference. You have to adopt good frequency planning. You have to conduct the drive testing. You have to verify the source of interference. If any repeaters are used, maybe if any overshooting of signal is there from a far away signal or from an altitude base station, or because of maybe overuse of frequencies, or maybe wrong frequency planning, the actual cause should be determined and they should be rectified. So interference mainly because of wrong overshooting of the signal, repeaters use, and then improper frequency planning. So that should be addressed. Antenna system. So even if the power is good, but the antennas are not radiating properly, means definitely it is a cause of high VSWR. High VSWR. What is VSWR? VSWR stands for voltage standing wave ratio. So voltage standing wave ratio we can determine. If the VSWR is more, it indicates that the radio frequency power you are transmitting through your waveguide or the RF cable from the source is not transmitting properly. It is being reflected. Some of the signal you are transmitting is getting reflected back. There is an impedance mismatch between the source and the antenna terminal. So ideally 100% of the energy you are radiating should be transmitted. The 100% of the energy you are radiating at the base station is not being transmitted from the antenna. It means there is impedance mismatch and there is a incident power is being reflected. And how to avoid it? Maybe simple thing is maybe how to check it. Maybe change the cable swap between the sectors and check it. You attend the faults. Maybe any bird nests are there at the antennas. Maybe clean the antennas. We change the connectors. If any bends are there and breaks are there, you have to verify it of the RF cables and attend antenna faults. Okay, so thereby this can be attended. And check for hardware issue and rectify it if any found. If suppose coverage issue is not there, interference is not there, antenna is good, neighbors are good, neighbors are properly defined in OMCR, RF environment is good, then you have to check for hardware, the TRX hardware or the control unit, and if any faults are there, you have to rectify it. Okay. And subsequently, you have to see the traffic reports, daily traffic reports, and you have to repeat the procedure to find. Suppose if you could not find it out on a single day after verifying all these trials, if you are following all these processes, but still you could not trace the fault, the only thing you can do is repeat the procedure, find out the actual cause. So another KPI that is there in second generation is TCH congestion rate or TCH blocking rate. So what you have to remember is, as I told you, more congestion is there means it is a disadvantage to the customers, and it should be as less as possible, and as per the TRI benchmark the congestion should be as less as possible. So what you have to remember is congestion rate should be less than or equal to 2%. Okay. And of course if the congestion is there, what are the different steps? So obviously the TRX should be increased. Obviously before increasing the TRX, you have to check the existing TRX whether the existing transceivers, the TRX are nothing but the capacity building blocks of the base station 2G BTS. These TRX transceivers, the transceiver cards, first of all, before increasing the capacity, before going for augmentation, we have to verify the condition of this TRX, whether they are taking the full load or not. You have to take the traffic reports at AX wise, and if the TRX are taking the full load of all the TRX are completely loaded, and then we can go for increasing the number of TRX. Okay, so that is how we can be doing that. And the other thing, what else we can do? So in order to increase the reduce the congestion rate, in order to increase the traffic handling capacity of a base station, the coverage can be increased. How the coverage can be increased? By adjusting the antenna parameters like azimuth, horizontal orientation, tilt, vertical orientation, height adjustment of the affected cell, neighboring cells, because neighbor cells will greatly affect the performance of every cell. It affects the handovers, it affects the cell selection, cell reselection parameters, and overall the system performance will be changed. Handover margin also adjustment, whether it should be 5 dB or 6 dB, depends upon the conditions. You have to adjust it. And finally we can also go for a dual band antennas if you are having more frequency. In addition to 900 band, if you are having 1800 band also, you can use both the bands and increase the channel capacity and reduce the congestion rate. Okay. Suppose if all these if you are having additional sector and infrastructure is there, you can also go for a new sector also. If you are going for a new sector, new cell will be established, and again frequency plan should be done, and more cells will be established. When the more cells are there, more capacity will be there. Obviously a sector, a new antenna if you keep, it will establish new sector. New sector is there, more number of cells, more number of cells means more capacity. So its congestion will be reduced. And last option, if all these things would not improve the congestion rate, would not reduce the congestion rate, go for new BTS in the affected area. So this is the Erlang B table. With the help of this Erlang B table only, the number of TRXs, how many number of channels are required will be determined. Okay. So Erlang B table, Erlang B traffic table is used by the planning people to determine the number of channels for a sector or for a base station. Usually here at the top, the column heads talks about the grade of service, GOS, grade of service. Grade of service we are taking as 2%. 2% means 98% is a success rate, 2% congestion is allowed. Grade of service means, grade of service 2% means nothing but out of 100 calls made in the network, we can tolerate up to 2 blocked calls due to non-availability of channels, etc. So that is the grade of service. Usually in GSM second generation, BSN has taken grade of service as 2%. For grade of service 2%, what is how many Erlang traffic you have to cater to for number of 1 channels? If 1 channel is there, it can cater up to 0.02 Erlongs. 8 channels are there. For one TRX can support 8 channels. One TRX can support 8 channels. One transceiver can support, one transceiver hardware in BTS can support 8 channels. 8 channels means 3.6 Erlongs. So 3.627 Erlongs. So one TRX can support 3.627 Erlongs. 2 TRX can support up to 9 or 8, because one time slot will be assigned 1 or 2 time slots for SDCCH. So it can support up to 8.2 to 9.8 Erlongs. 2 TRX can support up to this. 1 TRX can support up to 2.9 or 3.6. So roughly you can say that one TRX can support up to 3 Erlongs of traffic. More the number of TRX, more the Erlong it can carry. Erlong is nothing but traffic carrying capability, is a measure of units. the unit alarms. What are alarms? Alarms is traffic carrying capacity units. And one alarm means one call in one channel for 1 hour is called as one alarm. And call setup success rate. Another KPI. After SDCCH congestion rate, you have seen TCH congestion rate. The next KPI is call setup success rate. So this indicates, the name itself indicates how many successful calls are there in your network. Okay. So it indicates the probability of successful calls by a mobile phone, mobile station. Obviously the success rate should be as high as possible. What is the benchmark? It should be greater than or equal to 95%. This should be remembered. TCH congestion rate less than or equal to 2%, SDCH congestion rate less than 1%, and CSSR, call setup success rate, how many calls are successfully set up, it should be 95%. Okay, and this depends on SDCCH assignment, SDCCH drop rate, and TCH assignment. So all are interrelated. If the SDCCH are not good, setup also will be not good. Is an important parameter for evaluating the network performance. Okay, so CSSR is too low means what happens? The subscribers are not likely to make calls successfully. How to optimize it? Just now you have seen the last slide. We have to reduce the congestion of SDCCH. Drop rate should be reduced, TCH congestion should be reduced. For this we also already have seen the various reasons, various trials, what are the various trials you have to adopt to reduce the SDCH congestion and TCH congestion. Same thing have to be implemented here. Call drop rate. Call drop rate is a very serious thing. So when you are in an active call, when the mobile phone is in active call, the call is failed in between, it's called as call drop rate. Okay, and call drop rate are identified through SACH messages, SACH control channel. Slow associated control channel is a RF control channel, logical channel. So call drop rate should be less or high, it should be obviously as low as possible. So the drop rate as benchmark is, it should be less than or equal to 2%. And another counter is there. Radio link failure counter is broadcast and BCA channel, broadcast control channel, which also determines the call drop rates. If the handovers or handover issues are there, that also will result in a drop call. Handover means whenever a subscriber is moving from one base station to another base station and call transfer is not seamless. Calls are interrupted when you are moving from one cell to other cell. It's called handover, and if it is not moving well, it will be failed handover and also results in call drop. Even when the quality drops, call also drops. Quality means the CY ratio, carrier to interface ratio is reduced. So call drops maybe because of coverage, let us say coverage reduced, call drops. Quality reduced, call drops. These are to be addressed. How to reduce the coverage, how to improve the coverage, antenna parameters are to be adjusted, and quality you have to do frequency planning, or the sources of interference should be determined and it should be addressed. Okay. And handovers which are there, have to verify whether the handover failures are because of not defining the neighbors, and proper neighbor definition should be there in the OMCR, and we will verify it. And these are the various causes of call drop. One of the reasons what we have not discussed is when the transmission quality is poor, can drop. There also, if everything is fine in the RF, we also have to see the ABS interface. ABS interface means between the BTS and BSC. The OF link is having any issue. The OF link or the DMW link are having any issues. Instability is there, any quality parameters are affected, that also should be verified. Or another problem is hardware issue, TRS hardware, or VSW are high, or feeder cable swap, means swapping has done wrongly, that also may be affected. And unreasonable settings of handover parameters. Preemption is used in VMSC, so call may drop. The low priority MS will face call drop. So if that option is enabled in MSC core network, in order to provide service to the high priority customers, the low priority customers will face the call drop. So unreasonable setting of radio parameters. If all things are fine, you have to verify the various OMCR advanced parameters to verify the reasons of the call drops. So these are the various steps to reduce the call drops, and these are the causes. Optimization, obviously, see whatever reasons are there, that should be addressed. The radio parameters should be adjusted if any issues are there. As I told, maybe to address the coverage or quality issue, frequency plan and radio parameters, and the coverage holes are to be addressed by physical optimization. What is physical optimization? Physical optimization is nothing but tuning of orientation, height, electrical tilt or mechanical tilt. And setting up of radio link timeout parameter, and this will help in reducing the call drop. Okay. And so other some features are there, like in a rural site, if the uplink quality is poor, then we have to use RX level access minimum parameter, which should be set appropriately, which will result in reduction of the call drop. And link stability, also we discussed it in the priority. Hardware should be verified and neighbor cells should be optimized properly. So these are the various steps for reducing the optimization. Any doubts are there, you can ask me. And HYSR relates to the handover success rate. Handover success rate should be high or low. It should be as high as possible. And if this KPI indicates that the handovers are going well from whenever customer moving from one cell to other cell. So what are the different steps for handover success rate? Related to some points are covered for call drop rate, almost same. Only things will be the handover parameters will be there. Handover parameters should be defined correctly, and there should not be any confusion between BCCH and BASIC. They should be different. They should be the combination of BCCH and BASIC. Whether they are repeated or not, that should be verified, and congestion should be reduced. Most common issue this issue, suppose in a low HOSR is neighbors, they are not the best servers is not there in your neighbor list, means missing neighbors. Suppose the neighbor cells are there, you can find in your drive test or in your mobile, the neighbors are found but they are not defined and you could not latch onto that neighbor. That means they are not defined in OMCR, and you have to find out those cells, and you have to report in the OMCR to immediately record them. Maybe if one-way neighbor problem also will be there, feeder swap, I have discussed it. One-way neighbor handover, maybe one way side in one BTS the other cell is defined, but in other BTS the first BTS or the cell number is not defined, so it will be one way neighbor handover. Only one side handover will be there, on the opposite side it will not be taking place. Paging success rate. Paging success rate is the percentage of valid pages received by system, and it should be as less as possible, less than 1%. Okay, the paging the success rate should be great. Paging channel congestion should be as less as possible. So paging success rate should be greater than 99%, whereas congestion rate should be less than or equal to 1%. So these are the various steps for paging success rate. What is paging? Paging will help in determining, establishing the incoming call. So paging will help in establishing the incoming call, and paging will help in finding out the terminal customer, the mobile terminated call, maybe to find out to broadcast the SMS, to send the SMS, transmit the SMS. Paging is done. So paging, if any issues are there, paging success rate is less. If the paging congestion is more, what to be done? So now removal of non-existing cell side database in the BSCs is one thing. Correct lag dimensioning, split LA if paging discard is due to big LA. Okay. So correct dimensioning should be done. Location area code. If the location area code are not properly dimensioned, definitely the paging will be there will be an issue. More number of paging messages will be done. More number of paging messages means more load on the system. So properly dimensioning should be done. Properly LA borders, LAC borders should be defined. So if the LA size is more, it can be split. As we discussed, you should avoid SDCCH in the BCH and CCCH time slot. If this issue is coming, because as I said, out of 8 time slots in a RF carrier, 1 time slot will be dedicated for the control channel. If this issue is there, congestion success rate is there, we can assign SDCCH in a dedicated time slot. So remove the SDCCH congestion, eliminate the ABS errors, update the location update timers. If the issue is still not solved, you have to see whether the RF environment is poor, whether the coverage is poor because of any site outage, any sites are down, or if the poor signal strength is there, maybe because of any VSWR fault, or if they are having any obstructions. You have to conduct a drive test, you have to find out. Or finally, the paging strategy also should be changed as per your network size and topology by changing the location area dimensioning and then LAC codes, etc. So these are the automation steps. RACH success rate. What is this RACH? A random access channel. So random access channel success rate should be always high and as high as possible. If the success rate is poor or RACH congestion is more, it is a problem. So what is RACH and what is the purpose of RACH? RACH stands for random access channel. It is used by the mobile phone in the uplink direction. The purpose of this RACH channel is whenever you want whenever you want to make a channel request. Whenever a mobile phone want to make a channel request, what is a channel request? Whenever you want to have SDCCH channel, RACH will be used. Why you want SDCCH channel? Suppose if your mobile phone want to do location update. Suppose if your mobile phone to send a SMS in idle mode. Suppose if your mobile phone to make an outgoing call, or whether mobile phone want to make incoming call. For all these services, RACH is required. So RACH will make the SDCCH request. If the SDCCH request is acknowledged by system, acknowledged by the network, then only you can make a MO call, or you can get an empty call, or SMS in idle mode, or LU. how to optimize it? Just like that of the TCH success rate, the RACH success rate should be as high as possible. Any issues are there in the radio network, you have to address it. The discrepancies are to be avoided. Mainly, first you have to identify the bad performing cells for the RACH success rate. Take the detailed report, analyze the number of failures, why it is failing. As I told you, the failure mainly occurs because of their low coverage or low quality or the capacity issue. So if the low coverage is there, how to address it? The low coverage is there, the parameters are to be adjusted or the physical optimization is to be done. Parameter configurations should be done. They should be adjusted in the OMCR. And hardware issues, you have to check for hardware issues. The hardware faults are there in the BTS. Also you have to check the uplink interference and quality, and in uplink and downlink the imbalance is there, you have to correct that problem also. And some of the parameters in the OMCR, in the BTS parameters, which are also helpful in addressing this low RACH success rate, are mobile station max retransmissions, transmit integer, TS3122 timer, RACH minimum access level, control channel QoNF, and then bulk response, BL cases. So these are the various parameters which are to be helpful in, which can be adjusted to get the good RACH success rate. TBF success rate, temporary block flow. What is TBF? Stands for temporary block flow. What is TBF? TBF is a physical connection used by two radio resource entities to support the transfer of PDUs, packet data units. PDUs are nothing but packet data units, PDU. So, or you can say PDU or a protocol data unit also you can say. Protocol data unit or packet data unit is a single unit of information transmitted among peer entities in a mobile network. So PDUs, these packet data, how it will be transmitted in the radio channels. So it is a physical connection used by two radio resource entities to support the unidirectional transfer of PDUs. The physical connection, TBF, temporary block flow. So it's a radio resource on one or more PDCA channels, and it will be having this L2 layer, that is RLC and MAC blocks carrying one or more LLC PDUs. The success rate, usually when you are talking about data session only, these PDUs are used. Packet data, we are not talking about voice call but data calls. PDUs are, these TBFs are established both in uplink and downlink. And of course, what is the success? How when you're talking about data, it talks about how to optimize it. Just like TCH success rate, TBF success rate also will be similar. We have to identify the bad performing cells. We have to bifurcate the poor and good TBF performance cells. We have to verify whether uplink is poor or downlink is poor. And we have to take the detailed report, total requests, how many successes are there, how many failures are there. We have to analyze the detailed report, and we have to see whether the failure is because of congestion or mobile phone issue. And then we have to adopt the strategy, whether you have to go for a static PDCH allotment or dynamic PDCH allotments. The requests are high, we need to go for more PDCH. That means if the TBF congestion is there, you can also increase the PDCH, number of PDCH channels. Or suppose first, primarily before that we have to verify the hardware, the TRX alarms. If any notifications are there, you have to verify it, and you have to address the hardware issues. And you also have to verify all the parameters and whether they are following, whether they are being defined in the OMC as per the standards of the vendors. And we also have to redefine the PDCH strategy. If the voice utilization is not high, if the voice traffic is not high, we can dedicate more number of PDCH for data. Okay? You have to verify the DCH congestion. If the DCH congestion is not there, you can divert the PDCH and you can reduce the TBF congestion. This is also we can do it. And coming to the average, another KPI is the average GPS edge and RLC throughput. So here what it is talking about the throughput, the speed. Throughput talking about the speed. Identify the bad performing cells. Identify the bifurcation of the throughput. So identify the bifurcation of throughput means, so bifurcate the poorly performing cells and better performing cells, and you have to identify whether the uplink or downlink is poor. Bifurcation of poor throughput in case of uplink or downlink. After identifying the poor performing cells, in that cells whether the uplink is poor or downlink is poor, we haven't identified. And of course, you have to take the, like in the earlier case, detailed report, the total request, how many utilization coding scheme utilizations are there, everything you have to take the report, and you have to take the complete configuration dump of the poor cells. You have to verify whether the radio conditions are poor. You have to check the CY ratio, and you have to carry out the detailed drive test to analyze the cell in more detail for the is there any interference issue, is whether there are any overshooting of signal is there, whether any congestion issues are there, whether any handover issues are there, whether any interference issues are there, whether any poor frequency plan is there. Everything should be verified by conducting a detailed drive test if the issues are not resolved. And you have to check the GB congestion, the core network. The BSC or PCU, base station controller, and the packet control unit, you have to verify how the GB is there, that link, GB link. That link also should be verified, GB link. And also you have to verify whether any hardware issues are there. So you all noted between BSC and SDSN. So I think GPS support node, the interface is GB. Between BSS and SDSN, the interface is GB interface. The interface, that link, that transmission link, if it's not proper, if it is having congestion, if it is having any quality issues, if it is having any problems, obviously the GPS throughput, the RLC throughput will be down. Equipment faults also you have to verify, hardware faults, and also you have to audit for any disturbance in any standard parameter set. You have to verify, take the dump of all the parameters. You just have to cross check with the standard parameter set of the vendors. If there any mismatch is there, you have to address it. Same like the earlier case. Same thing for the another parameter KPI is there, downlink multi-slot assignment success rate. Okay, the downlink multi-slot assignment success rate means in case of GPRS, unlike in voice call, we can assign multiple slots. You can assign not only one, you can assign 2, 3, 4 depending on your parameter that is set in the OMCR. Multiple slots can be assigned. As per the specification, you can assign all the 8 time slots, but that is not feasible. You cannot assign channels for voice. So how many multi-slots can be assigned? If the multi-slots are not assigned, maybe congestion is there, or maybe some parameter issues are there, or maybe some hardware issues are there, or GB congestion is there, just like quality issues are there. All these steps, like in TB flow congestion, TB flow success rate, you have to verify it step by step, and you have to increase the success rate if any issues is there. The purpose of multi-slot assignment in GPS is to improve the speed, to improve the throughput. Multiple traffic channels can be assigned at the same time. Okay, we have seen so far. You have seen 2G KPIs. Now coming to 3G KPIs. These are the 3G KPIs. 3G KPIs are classified in various categories. What are the various categories? Accessibility. Accessibility is nothing but mobile phone getting the access of the network. Here what will be there? The call setup success rate, which we have seen 2G, same thing. Apart from it, another thing which is there in GPRS, that is PDP context activation. PDP context activation. What is this PDP context? PDP context in GPRS also it is there. PDP stands for Packet Data Protocol. PDP context is nothing but Packet Data Protocol, and the purpose of this PDP context is the barriers. It will establish a barriers which will be acting like tunnels used to connect the user equipment to the core network. So these PDPs context, which will, whenever it is established, it will establish a direct tunnel from the mobile equipment to the core network in order to use the data service, or in order to use the core network services. Okay. So these PDP context, whenever PDP context established, means there will be direct tunnel between mobile phone and up to the network, GDS and RSDS. In SMS success rate or MMS success rate, this is the accessibility. Accessibility talks about mainly the success rate. Retainability. Retainability means after access is given, after mobile phone is given access by the network, the next job is to retain that customer for a maximum period of time, or for the time until the customer want to disconnect the call, until the customer want to disconnect the session. It's called retainability. So retainability is addressed by what KPIs? Call drop rate and PDP context drop rate. So call drop rate refers to voice call, PDP context rate refers to the data session. Okay. Call drop rate we are referring to, since 3G supports both CS, circuit switching, and as well as packet switching. When you are talking about call drop, it talks about circuit switch. Packet switch talks about PDP context activation. So other one is, if you are talking about data, service integrity is must. PS throughput, packet switching throughput, how much speed is being delivered to the customer. And the mobility and the feature, that is another which you also have seen in 2G, the success rate, handover success rate. Mobility is an important feature of any mobile phone. The mobile phones are naturally, they will be moving from one area to other area. They move from one room to other room, or one home to one house to other house, or one place to other place, one state to other state, one country to other country. So the success rate should be as high as possible. SHO means soft handover success rate. When you are handing over between the same frequency, in WCDMA SHO is used. When the frequencies are changed, it's called as hard handover success rate. So whenever there is a handover from one frequency to other frequency, it's called hard handover. When the frequency is changed during the handover, it's called hard handover. When the frequency is not changed during handover, it's called soft handover. Usually soft handover will be there in 3G mostly. Hard handover will be there if you are having more than two 3G frequency slots. Of course, in BSNL case, we are having only one frequency slot, so it's not an issue. And inter-RAT handover success rate, this is also an issue. We have to verify in BSNL also. Inter-RAT means radio access technology. Inter-RAT means between 2G to 3G handovers. If the 3G if the customer 3G customer, the signal is not there, 3G signal is not there, and 2G signal is there, the customer call should be handed over to 2G. So that's called as inter-RAT handover success. So inter-RAT handover, if the inter-RAT handovers are more success rate is more, it is not there, the success rate will be less. The problems are there, it should be addressed in the OMCR. If the parameters are faultily configured, that should be addressed. And another important KPI is delay or latency. This we are talking, and the latency is reducing as we are going to new releases. How the latency will be measured: call setup delay, PDP context activation time, RTT, radio transmission. So I'm sorry, RTT, the round trip time, the round trip delay or the round trip time. Call setup delay or PDP context activation time or round trip time all signifies the latency. And finally the availability. Availability, if the BTS is down, all these factors will be not important. First of all, the BTS should be available. The BTS is down, no accessibility, no retainability, no integrity, no mobility, no service, good experience. Delay, complete delay, full delay. So you should be seeing worst cell rate is the factor for the availability. Worst cell rate, BTS which are down for maximum period of time, that should be addressed. Those problems should be addressed. So these are the various KPIs and various categories and various KPIs rather than the 3G. Okay, and the 3G KPI classes are also there. What are different KPI classes? Capacity class, they are talking about the capacity parameter, and coverage class, mobility class, QoS class, resource usage class. So these are the various parameters that are there in every classes. Just go through the various parameters. If you have any doubt, you can ask me. Basically, these KPI classes are indicating in the radio access network. And finally, coming to the LTE KPIs. You can see LTE KPIs just like that of 3G KPIs. Same. Accessibility will category, retainability category, integrity, talking about throughput, availability, whether the BTS is down or not, mobility, handovers, utilization, whether the resources which are deployed are utilized or not, the traffic reports, and latencies, the delay. So all these are important parameters in the LTE. Okay. So any doubt are there, you can ask me. Okay. So these are the various KPIs. And in accessibility KPI, what are there? RRC setup success rate, ERAP setup success rate, and call setup success rate. RRC stands for, any idea what is RRC? Radio resource control. Same thing which is RRC in 3G, 4G, 5G, RRC word is there, radio resource control. ERAP stands for E-Neutron Radio Access Bearer. Radio Access Bearer. So E-Neutron means Evolved UMTS Terrestrial Radio Access Network. E-Neutron means 4G. So all these success rates will be measured in LTE KPI. Retainability, as we discussed, call drop rate, circuit switch calls, packages both are discussed. And mobility KPI, talking about handover. So in LTE, since OFDM is used, intra-frequency, inter-frequency, inter-RAT. So inter-RAT is between technology, between 4G to 3G, and intra-frequency, inter-frequency depending on the how frequency you are using. And integrity KPI, throughput, as we discussed, and availability, cell availability, utilization, talking about mean active dedicated EPS bearer utilization. So this is the another important parameter that is specifically there in the LTE KPI. What is EPS? EPS stands for Evolved Packet System. Evolved Packet System is end-to-end. All IP network is called as Evolved Packet System. In LTE, one of the feature is it is an end-to-end full IP network. So mean active dedicated EPS bearer utilization. How many bearers are utilized? On average, it will measure how the network capacity is utilized. So depending on that, the augmentation or reduction of the resources are done. So these are the various KPIs which you have seen in this module. If you have any doubt, you can ask me. In the sixth chapter, you have seen KPI reports for 2G, 3G, 4G.